Okay, so now we're evaluating common logarithms, which, if you guys remember from the Prezi, all a common log is, if you see something that's different about these problems, is the base is missing. You're probably like, what the heck, Miss Long, where is the base? Well, guess what? If you don't see a base, secretly there's a 10 in its place. Alright, so all common logs are. That just means if you don't see a base, secretly there's a 10 hanging out in its spot. Okay, so you don't have to write the 10 in there, but if it helps you to remember that 10's hanging out there, go ahead and write it in. Alright, and then from here, these kind of progress like our last problems did. So if you think you understood example 3, 4, 5, and 6, 7 and 8 from here on out are the exact same. So go ahead and pause the video and try 7 and 8 on your own if you would like. Okay, so if you remember from before we start, our goal is to convert these logs into an exponential, which the way we do that, we start by setting our logarithms equal to an x. After that, we have to convert our logarithms into an exponential. Okay, so the base of my log is the base of my exponential. So since the base of my log is a 10, it is now going to be a 10 for my exponential. Alright, and remember you guys, these two just trade places. Okay, so my x is going to hop into the exponent of my 10. And then the 1000 over here is going to hop to the other side of the equal sign. Okay, or if you're one of the people that like to do the roundabout way, okay, you can also do 10 to the x power equals 1000. Okay, whichever makes more sense to you. Okay, alright, now from here, the goal is to get the same base on both sides. Okay, so let's think about a number that goes into both 10 and 1000. Okay, so you probably can say like, well, Miss Long, 2 goes into 10 and 1000. Okay, well the problem with using 2, our goal is to raise these to an exponent. And if you think about it, I can't raise 2 to any power to get 10. 2 times 2 is 4, times 2 is 8, times 2 is 16. So not only do we want to find numbers that divide into these, we want to find numbers that also you can raise to an exponent to get these numbers. Okay, so you could also say like, well, 5 technically goes into 10 and 1000. But again, we're trying to raise numbers to exponents. So if I try to raise 5 to a number to get 10, well, 5 times 5 is 25. That is not going to work. Okay, so when we do this, we need to pick numbers that not only divide evenly into both numbers, but also you can raise to a power of both numbers. Okay, so it's kind of a lot to think about. So the next number up, we tried 2, we tried 5. The next number that divides evenly into 2 and 1000 is 10. So let's think about it. Well, 10 definitely will go into 10. 10 to the first power is 10. Now over here, here's a little trick. If you guys see numbers with zeros, okay, that is equivalent, the exponent on that number is equivalent to how many zeros there are. Because let's think about it. So there's 3 zeros here. So if I'm following my little trick, that means 10 to the third power should give me 1000. So let's see if that works. So 10 times 10 is 100. 100 times 10 is 1000. Okay, so whenever you guys have 10s, okay, so I'm going to go ahead and write my bases on both sides. We figured out that 10 is our base. Okay, whenever you have a 10 to an exponent and you have a bunch of zeros, okay, the secret is you just count the zeros and that's the exponent. Okay, so since there's 3 zeros here, it's going to be 10 to the third. Okay, you can only do that with 10s though, and if you have numbers with a 1 and zeros, that's it. Okay, so now that we have the same base on both sides, if you notice we have that 10 on both sides, okay, now we can set those exponents equal to each other. Okay, I can set those equal to each other. So this will be x equals 3. Okay, or you can start from the top and say log of 1000. Remember, you don't have to write in the 10 unless you want to. Equals 3. Bam, that one is done. Alright, so if you think you understood that, again, you can also pause the video now and try example 8, which we're going to get going on example 8 right now. Okay, so example 8 is the same thing that we've done from example 3 to 7. Okay, we're just now using common log. So the original problem didn't have the 10. Okay, so remember, when you don't see a base, the base is secretly a 10. Okay, so let's get going. So the first thing we do, we always set that log equal to an x if it's not equal to anything we're trying to evaluate. Okay, next thing, we have to convert that logarithm into an exponential. Okay, the base of my log is the base of my exponential, which the base of my log is this lovely 10 right here. So that will be the base of my exponential. Okay, and then remember, these guys right here will trade spots. So my x is going to hop into the exponent of my 10. And the 1 over 100 is going to hop to the other side of my equal sign. Or again, you can say 10 to the x power equals 1 over 100. Whichever way works. Alright, if you notice, we have this fraction. Okay, so if you think back to example 5 and 6, we're using the same component. Okay, so if you notice, 110 does have something that goes into both of them. So if I could bring that 100 to my numerator, okay, I could then make the same base on both sides, which is what we are trying to do. Okay, so I have my 10 to the x equals, remember the way this is secretly to the first power. When we move a number to the numerator, all we do is change the sign of our exponent. So since it's a positive one, that bad boy is going to change to a negative one. That's it. Okay? And then from here, our goal is to get the same base on both sides, which, remember from before, not only do we want to think of a number that will divide evenly into both of those numbers, we also want to think of a number that we can raise to an exponent and get each of these numbers. Okay, which this is going to be the same thing as this side since we're dealing with powers of 10. Okay, so the number that both divides evenly into 10 and 100, and I can raise an exponent to it, is a 10. Okay, so 10, I'm going to have a 10 on both sides. Okay, so all I'm doing right now is I'm thinking about 10 to what power will give me a 100. Okay, and I'm putting the negative 1 on the outside so I don't forget about it, but I know that it's not associated with 100. Okay, so 10 to what power will give me 100? Well, guess what, you guys? That's a 2. 10 times 10 is 100. Alright, and before we can set exponents equal to each other, I need to combine my exponents. Which, remember, if you have an exponent right next to an exponent, you just multiply those bad boys together and you will get your new exponent. So 10 to the x equals 10 to the 2 times negative 1 is negative 2. Alright, and now, if you guys see, I have the same base. Yay! And since I have the same base, I can set my exponents equal to each other. Just drop down my exponents and set them equal to each other. That's all we're doing. Okay, so x equals negative 2 is your answer. Or you can rewrite the whole log problem. So log, I'm not going to put the 10 because usually when you see common logs, you don't see it. Okay, so log of 1 over 100 equals negative 2. That's all that log equals. Isn't that exciting? Alright guys, that's it with 7 and 8.